Hi, I'm Therese, and in this video I'll show you how you can control things in your home using Arduino. We will base this on project 15 in the projects book that shows you how to control your sound recorder, but you can basically control anything you like that has a type of button shown in page 158 in the projects book. I've chosen to control my fan since it's summer. What you need to look for is a device that has a button that you can easily access, for example in some remote controls. But before you start opening any device, remember that this is no longer a beginner's project. Make sure that you understand all of the electronic concepts in all of the previous chapters before proceeding. Also know that by opening any electronic device, you might void its warranty and also destroy it. A new component we will introduce in this project is an optocoupler, which is an integrated circuit that will allow you to control the button without having any electrical connection between the Arduino and your button device. This way, our external device is protected against any electricity that comes from the Arduino board. You can read more about the optocoupler on page 157 in the projects book. I've also added the temperature sensor from the kit to this project, so the fan can turn on at certain temperatures. It's not in project 15 according to the book, but you can integrate any sensor you like for this. Apart from the temperature sensor, the starter kit also comes with light sensors, a vibration sensor, and a tilt sensor. Now let's open our device. I've chosen the remote control for my fan because it has these type of buttons that I'm looking for, but also because it would be cool to automate it according to the current temperature. I'm taking out the battery first, and I can actually see the circuit inside. These devices can be designed in many ways, so your device might need to be opened in a completely different ways. It's good to have a set of small screwdrivers for this. I figured that my remote controller had this cover just glued on top of the circuit, so I'll carefully remove it with a screwdriver. I can see that the buttons consist of metal plates with this fork-like pattern that is very common for many electronic devices with push buttons. One side of the pattern needs to be connected with the other for the circuit to close and the button to be pushed. The lid has these hollows with conductive material in the bottom. When this conductive material touches the metal plate, both sides of the pattern will be connected through the material in the hollow. This means that if I take a jumper wire and connect each end to a side on the metal plate, it will activate the button. I'm locating the on and off switch to this one according to the lid, and we can actually try this out before creating the entire circuit. The fan is on! Great! Now we can connect it to a circuit with a board and optocoupler. Make sure that you have nothing connected to your board, and I've started to prepare the board with the power and ground rails here as usual. Then I'm placing the optocoupler so that each pin is connected to a unique row, which means that I have to place it here over the gap. In one of the corners, you will see a circle. This means that this is pin number 1. If you can't see the circle, there is also an edge or groove that you can feel with your finger on the left side. The first pin, pin number 1 on the optocoupler, leads to the LED inside, which means we need to connect it to a digital pin to turn it on and off. We will connect it through a 220 ohm resistor, as we always do when we connect LEDs, so it doesn't get burned out. The second pin, the middle pin on the left, goes to ground. Now we just need to connect the two metal plates on the remote to these two pins here. We can do it just by taping the two ends on a jumper wire to the plates. It won't last for long, but it's enough for testing until you know that you want to solder it in place. Finally, I'll connect the temperature sensor in the same way as we did in project 3, since we want to turn on the fan whenever a certain temperature is reached. And that's it! Let's modify our code to make this work. The code in the book is designed to close a switch to simulate a button being pressed, and then wait for 21 seconds before the procedure is looped. This can be useful, for example, when you want to play a sound from a sound recorder with a time interval between. But in our case, we want to turn on a fan whenever it gets warm, so we'll have to modify it. I will start by adding a constant variable for the temperature sensor pin before the setup. I will also add a variable to store the sensor value and convert the temperature value in, as well as a boolean to remember if the fan is on or off. We will start with assuming that it's off. In the loop, I want to start by reading the sensor value, converting it to a temperature in Celsius, and storing it into the temperature variable. If you don't know how to do this, check out the video for Project 3, Lava Meter, or the datasheet for the temperature sensor you have. We will use an if-else statement to check if the temperature is over a desired temperature in order to turn on the fan. Inside the if statement, we will also check that the fan is not already on. If you haven't used an if-else statement, check out Project 2 in the projects book. Now we can add the original lines of code for turning on the button and change the delays. The time for the button to be on can vary, and you might need to test what time works for your button. Mine worked with 100 milliseconds. We also have a 10-second delay after the button has been on, so the fan can be on for a while in case the temperature is going back and forth close to the threshold temperature. But you can modify this to any delay time you like. Next, we need to add the code that turns the fan off in case the temperature drops. After the if statement, we will add an else if statement that checks if the temperature is below the desired and that the fan is also on. We'll also set the fan state to off and have a 10-second off time here. Now we can upload the new code to our board and test if it works. I will heat the temperature sensor with my hand to activate it faster. It works! And now that the temperature has dropped, the fan turns off automatically. Cool! Can you think of other projects to create using this method of hacking buttons? Visit Arduino Project Hub for inspiration and tutorials. This was our last project from the starter kit, and it's time for you to start tweaking them or to create and design your own projects. Remember to share them with us, for example on social media. Thank you for watching. Bye!